Hi, I'm Antoine Ducoin. I'm professor in hydrodynamics, and today I will present you the Master AMASONE program.
Good morning, I am Lionel Chantaz. I am working at Centrale Nantes as assistant professor, and I am supervisor of first year of the master track in ocean engineering.
So the AMASONE Master program is a program in maritime technology. The originality of the program is that it is held in both universities, in Naval Academy and Centrale Nantes. So I'm responsible for the M1 and M2 program with another professor of the Naval Academy, which is not here today. So the AMASONE Master program, as I said, is accredited both at the Naval Academy and the Centrale Nantes universities. The two universities are not in the same location. The Naval Academy is at the very west of France, whereas Centrale Nantes is a little bit more southeast of the France. There is also a third university called the National Maritime University, which is located at Centrale Nantes campus. Okay, so now I will present you the program in M1 and M2. For the M1, it's only at Centrale Nantes. The 2 semesters are in Centrale Nantes. During the first semester, the students will learn basics of fluid mechanics for fluid mechanics and marine hydrodynamics, but also some basics in mechanics like mechanical engineering, programming and algorithmics and numerical methods. Those basics courses are very important because students come all over the world with different backgrounds, and for us it's very important that all the levels are the same for the second semester. Students have also a language course and a specific course called Maritime and Navigation Knowledge, which is held at the National Maritime University, which is at Centrale Nantes campus. So this specific course is held at the ENSM school. The ENSM school train engineers for maritime transportation. So the students have around 60 hours of trainings, which is about ship operation and ship handling, mostly. Ship navigation, basic knowledge, maritime English, basic safety communication, and safety and security codes. So the students will also train in a simulator. So they have 2 simulators, a bridge and a propulsion simulator, where the students are put in a real configuration, and they have to do maneuvering in a complex environment and take a decision. During the second semester, students continue to specialize in fluid mechanics. They have also classes in energetics, propulsion and thermal machines. These classes are also very important in the AMASONE Master program. It's a second aspect of the program, which is quite important. The specific course, so it's thermal machines, as I said, and also lab in propulsion system. I will detail those 2 courses in the next slides. During thermal machines, students will have about 30 hours of class with a professor which actually work in a company called MAN-ES or Everlands. The new name is Everlands, who is a manufacturer of propulsion device mainly for boats. And they have a class about system dedicated to ship propulsion. And the main focus here is on diesel engines. And at the end of the course, there is also a visit with myself and all the students at Everlands. The lab in propulsion system have two different aspects. The first aspect is the experimental lab in propulsion system, which is basically the application of the thermal machine class. We have a big experimental facility at Centrale Nantes to test motor in real conditions. The second content is a lab in computational fluid dynamics about the simulation of a marine propeller, where we study the performance of a specific ship marine propeller. And later in M2, the students will have an experimental lab with the same propeller. I will talk about that a bit later. So now I will pass to the M2 program. So the M2 program, in the M2 program, the students will move to Brest at the Naval Academy. So for the specific details, they have to move out from their place in Nantes, find a new lodging, and then move to Brest. Usually it's quite it's not easy, but it's okay. They have also help from the secretary of the Naval Academy in Brest. And during the second year, in the first semester, they have theoretical class like at Centrale Nantes, but more specialized because it's M2. And they have also applied lectures in naval engineering and language course in French for the foreign students, and in other languages for the French students, of course. And during the second semester, they have a master thesis to perform, either in a company or in a lab, to do some research. So as for the class now, the teaching at the Naval Academy is, the content is about training on ship, about naval engineering. Advanced hydrodynamics, so this class is a big class where they have research, experimental hydrodynamics. They have advanced class in, for example, in lifting profiles, and also about ship stability. So it's all the specialty of the hydrodynamic lab at the Naval Academy, basically. And they have applied classes about naval engineering, like maritime initiation and leadership, where students learn about leadership, how to lead a ship in a naval environment and in a practical environment. They have a class in knowledge of maritime environment. So this class is about basically all the other aspects which are not specifically in the naval engineering, but very important still, like the physics of ocean, marine geoscience, and basically all the maritime environment, and some very important scientific class such as acoustics and electrical propulsion. I will talk about the first class, as I said, the training on ship, in the next slide. There is also one class in experimental lab in hydrodynamics at Centrale Nantes, where students move to Nantes during 1 week. They have lodging, we take care of this, and they do experimental labs at the basin at Centrale Nantes. So about training on ship, because it's specific and usually it's one of the main, I would say, the main advantage of the master is that students do ship maneuvering and go on board ship. And this is during this class, Training on Ship, where they have some theoretical lectures about training on ship, like basic security training, navigation training, and so on. And then at the end of the class, they go on board a military ship and they do maneuvering with instructors. And sometimes also they go on board a sailing ship. So during just before Christmas, students go in Nantes again to do the experimental lab in hydrodynamics. So we have 3 big basins at Centrale Nantes, which is quite unique in France in terms of academic basins. They learn about experimental hydrodynamics, ocean engineering, ship resistance, ship maneuverability, measurement and signal processing to post-process the data, and propellers hydrodynamics. So during this week, the students perform 4 experimental labs. I will explain 3 of them in the next slide. So during this week, the students perform 5 experimental labs at the basin at Centrale Nantes. So during this week, students perform experiments in the unique facilities at Centrale Nantes. They do basically 5 experimental labs, including a lab in the towing tank, where they measure the resistance of a ship. They perform ocean and shallow water wave experiments, where they perform experiments of a wind turbine, for instance, of an offshore wind turbine. They also perform experiments in a recirculation tunnel, also called a flume, where they study the performance of a propeller in an open water environment, including also the situation where the propeller is subjected to ventilation, where the free surface gets close to the propeller. So those experimental labs are quite unique and are also used for the research. So the students can also touch really the research of Centrale Nantes. So after this semester, students perform a master thesis, usually in a company, including a shipbuilding company, certification company, offshore industry, but also sometimes in research in universities. So now about the career opportunities, it is mostly in the maritime industry. After the Amazon Master Program, students have quite different positions. However, it is mostly in operation. It is the goal of the Amazon Master Program. The position goes from mechanical engineer, design engineer, process engineer, exploitation engineer, and marine system management. The fields are mostly in the maritime transportation and maritime equipment and shipyards, as well as the energy field, including wind and marine energy. So why choose this master program? At first, we have high scientific level, but also one of the specificities of the master program is that we have navigation classes for ship operation, management, and maneuvering, where students have classes inside 2 different simulators, both for military and maritime transportation ships. And students go on board ships and different ships because we have sailing and military ships. We have also classes on unique research facilities, both at Centrale Nantes, where we have experimental basins, and also at the Naval Academy, where we have classes inside a hydrodynamic tunnel. Thank you for your attention.
Good morning, I am Lionel Chantaz. I am working at Centrale Nantes as assistant professor, and I am supervisor of first year of the master track in ocean engineering. The master track in ocean engineering is dedicated to hydrodynamics for ocean engineering. So hydrodynamics is a branch of fluid mechanics dedicated to incompressible flows such as water. And in the following, we will consider usually the influence of the interface between water and air, which is called the free surface. Ocean engineering is an application of engineering science to the study, the analysis, the design and the optimization of structures operating in ocean environment. Thus, you will focus on the study of free surface flows around marine structures. Free surface flows are composed of water waves, marine currents. Sometimes you will have to consider the effect of wind on these marine structures. These surface flows will interact with various marine structures, such as a ship, offshore wind turbine, other marine renewable energy converters, or any other offshore fixed or floating marine structures. These marine structures will be subjected to hydrodynamic loads and motion, which will characterize their behavior and performance. And the final purpose for you will be to gain some knowledge to be able to evaluate the behavior and performance of these marine structures in order to contribute to the design and to optimize the design of these marine structures, to improve security during installation and use of the structure, and more generally to promote the decarbonation of energy production and maritime transport. To study these free surface flows around marine structures, there are several steps. The first one is the understanding of physics of flows and the relative importance of the physical phenomena involved in the different problems you will consider. The second step is the mathematical modeling of this problem, and if possible, the simplification of this mathematical modeling. The third one is when you have a mathematical modeling of a problem, to the possibility to develop and use numerical methods to provide some results. And in parallel, you can use experimental methods. It must be noticed that numerical methods and experimental methods are complementary. This process will concern different classic problems of ocean engineering, for example, marine environment, where you will study generation and propagation of ocean waves, ship resistance, where you will consider ship advancing in with a forward motion in calm water, seakeeping, where you will study the interaction between bodies and incident waves, or moorings, which allow structure to be held in a fixed position. Other problems which will be studied are maneuverability, for example. Concerning the curriculum of this master track, the total duration is of the studies are 2 years. These 2 years are decomposed in 4 semesters. In the first 3 semesters, you will have a combination of common core courses, specialty courses, which can be theoretical courses, tutorials, or lab works. And in each of these semester, you will have a course in foreign languages. So if you are English native speaker, this course of foreign languages will concern French language. So during this first 3 semesters, you will have a progressive specialization and professionalization, and you will have an initiation to research with project that you will do with PhD students of the LIA lab. The second semester of the second year will be devoted to a master thesis, which will be done in a company or in a research lab. Each course during these 2 years is worth a specific amount of ECTS. ECTS means European Credit Transfer System, and it is corresponding to a certain amount of workload. And to validate each semester of this master, you will need to gain 30 credits, so 30 ECTS for each semester. Here you have a list of the different courses of the first year. So in white you have common core courses, and in red you have some specialty courses dedicated to hydrodynamics for ocean engineering. So for example, in the first semester you will have a Marine Hydrodynamics 1 course, where you will study the state of the art of activities connected to marine hydrodynamics in industry and in research. You will have an introduction to experimental approaches, to wave structure interaction, and to ship stability. In the second semester, you will have another course entitled Marine Hydrodynamics 2, where you will have an introduction to mathematical models, numerical simulation, and lifting profiles. And finally, during the spring semester of the first year, you will have a research project where you will work on an innovative topic with a PhD student of the LIA lab. For the second year, you have only specialty courses dedicated to hydrodynamics for ocean engineering. So in the list, you have 3 courses in red, which are underlined in red, which are mandatory. You have all elective courses, so you will have 3 courses among this list of 8 elective courses to select. It must be noticed that in this list you have an experimental hydrodynamic course, which is quite unique, because during this course you will have some practical lab work in the experimental facilities of the LIA lab with devices which are unique in terms of size and capacity in the French and European academic field. So you can see on the slide on the top a view of the towing tank of Centrale Nantes, which is used for ship resistance evaluation. During the second semester of the second year, you will have to do a master thesis. So the duration of this master thesis is 6 months. It must be done in the field of ocean engineering. It can be done in France or abroad, in a company or in a research institute. So if the company or the research institute is located in France, you will have a salary which is corresponding to the French law. And you will have to do a report and a defense of your work at the end of August, so just before the end of your studies at Centrale Nantes. On the slide, you have 2 examples of previous master theses which have been done by students of the master track. So the first one is about floating offshore wind turbine and was undertaken in the University of New Hampshire in the United States. And the second one is about the numerical optimization of hull form and was done in a French company. Concerning the academic requirement, if you want to apply for this master track, you will need to have a bachelor degree or equivalent in a field related to science and technology. So most of the students at Centrale Nantes have a bachelor in mechanical engineering or in naval architecture and ocean engineering, but some of them have a bachelor in civil engineering, applied mathematics, physics, or aeronautics. After your graduation, you have many opportunities concerning your first job. You will have the possibility to work in different fields, for example, marine renewable energies, offshore industry, naval industry, maritime transportation, or in society of classification. And different positions will be available. For example, you will have the possibility to work in a research and innovation team, or in a design office, or in project monitoring, or as exploitation engineer or installation engineer. Another possibility after the graduation is to start a PhD, which is a research work with a duration of 3 years. It can be done in a research lab in France or abroad, and it can be possibly connected with a research project supervised by an industrial partner. Here you have some statistics about PhD students which were graduated with a master in ocean engineering. So you can see that 2/3 of the students decide to do a PhD during the master thesis or after the graduation. It is the first point. And the second point, about 20% of the students have found a PhD thesis in 1 month maximum, and about 70% need less than 1 year to find a topic. On this slide, you will find some arguments to convince you to join us at Centrale Nantes. The first one is that most of the teacher researchers that you will have during your courses are working in the LIA lab, which is a laboratory in the field of hydrodynamics with strong expertise. The second point is that you will have the possibility to do some practical lab works in the experimental test facilities of the LIA lab. And these facilities are unique in terms of size and capacity in the academic field. The third point is that this master is fully taught in English. The last point is that Centrale Nantes and Nantes University were ranked 41st for marine and ocean engineering according to the Shanghai Global Ranking of Academic Subjects in 2023, that show again the attractivity of Nantes in the education and research field of ocean engineering. Thank you for your attention. Please feel free to contact us for more information, and I hope you will join us in the following years.